Hello everyone, you are welcome to today's lesson. And in today's lesson, we are going to have a fresh look at this topic that we all have on our screens, algebraic expressions, but the word problem to algebraic expressions. Okay, and this particular topic that we are going to look at is one of the topics that was students find it a challenge. Okay, but believe me, you, by the grace of God, by the time we finish going through the entire lesson, okay, that will be a story, okay, of the past. Okay, all right. So now let's quickly go through the learning objective for today's class. So for today's class, okay, basically you should know some of the phrases, common phrases that you will need, okay, or you will encounter whenever you are dealing with word problem. And I will group the phrases in terms of what the basic arithmetic operations. So I will group them under addition, okay, the phrases that you see, subtraction, okay, multiplication, division, any I will add equal to. So once you are able to recognize these phrases, okay, anywhere you see them, you will know exactly, okay, the operation that will be involved. Okay, so as usual, stick and stay with me. I am Mr. Hackman, your usual facilitator. Okay, so quickly let's go and look at our next slide. So common phrases and the word problem. So addition, these are the phrases that you have to watch out or look out for, or whenever you see, you should know that we are dealing with what? Addition. So when you see some, we are talking of addition. When you see added to, increased by, more than, and some other equivalent what phrases. So these phrases are not exhaustive. You have others, but these are the common ones. Okay, then when it comes to subtraction, we have subtracted from, less than, decreased by, difference between, minus, shorter than. Okay, then it means you should also know that you are dealing with this particular operation, subtraction. So quickly, let's go and look at that of the multiplication too. So when you see product, you see times multiplied by, twice as large, three times a number. So you have to see times there. Half of a number. Okay, obviously you should also know that we are dealing with multiplication. Then division, we have to see divided by quotient of. Okay, so these and some other equivalent, okay, phrases, okay, will be in play. Then let's go and look at the last one, which is the equal to or equals. So you see S will be is equal to, then it means we are talking about what? The equal to sign, and that must be introduced. Is my point well made here, my professors?
Yes, sir.
Okay, very good.
Yes.
So now let's go and look at what? Word statement and how to write that in terms of what? Algebraic what? Representation. Okay, so this is it. The first part of the table, you know, we are dealing with word statements, and the second part will be the algebraic representation or symbolic representation. So now that we know the phrases, let's see how best we can put the phrases in use here. So 5 times a number. So whenever you see times, then we are talking about multiplication. So 5 times a number x means 5, okay, multiplied by x. So that is 5x. You get it? So that's how you write this long statement here in English in terms of what? Maths. Okay, then 3 more than a normal x. So remember we said when you see more than, we are talking of what? Addition. So it means 3 more than the normal x will be what? Okay, 3 plus x or x plus 3, which will be the same. Is my point well made?
Yes, please.
Okay, and in the same way, a normal x decreased by 7. And normal x decreased by 7. So we said decrease, whenever you see decrease or decrease by, we are talking of what? Subtraction. So it will be x, okay, minus what? 7. So that's exactly what we have here. Then 1/2 of a normal x. So it means I'm taking half of what? Of x. So it will be half times x, which is half x, or x over 2. Then the square of a number x. So here your number is x. The square of it will be x squared. Then 9 added to twice a number x. So twice my number x is 2x. 9 added to that will be 9. So plus 9. So it will be, okay, 9 plus 2x. So 9 added to, okay, twice what the number x. So it's the same as 2x plus 9 is the same thing. You know, addition is commutative. Then the last but not the least, 4 times a number minus 8. So I can see times here, one of my critical, okay, words that I have to know, okay, for me to know that I'm dealing with multiplication. I can see minus there, so which is subtraction. So 4 times a number. This time around, I didn't define my number, but in actual fact, it's supposed to be, okay, a number x minus 8. So I'm taking my number as x. So it's 4 times x, okay, then minus what? 8. Is my point well made? Okay, are all these well understood? Moving from the word
Yes,
statement to the algebraic representation or symbolic,
yes,
okay, statement, or fine. So if that's the case, then now let's move on to, okay, what we have here. So you are going to convince me that you have understood. Okay, at a point I will pause then ask you to give me your answers via the chat. So the class is going to be very interactive. Okay, so let's see the first word example. Write each of the following statements in algebraic expression. So we need to get the symbolic, okay, or algebraic representation of the statement that we have there. Okay, so now, as usual, solution is what we write first. After solution, what are we supposed to write? Okay, questions are numbered because we are supposed to number our solution. So in this case, okay, we have question solution to major question number 1, but 1 what? I. Okay, so I, okay, you can choose not to write given this. We are going to write the answer straight away. Okay, so in that case, I'm going to, okay, because my variable has been defined, okay, I don't represent any unknown by a variable, so I can draw my conclusion straight away. So let's break it down. 6 times a number x, so that means, okay, 6 times x, so 6x. Is my point well made?
yes, please.
Decrease is for
Yes.
which operation? Decrease by is for which operation? Addition, subtraction, multiplication, division.
Subtraction.
Subtraction. So decrease by 4
Subtraction.
will mean minus what? 4. So that will be, okay, the algebraic expression form of the statement that we have there. Is my point well made, my professors?
Yes, please.
Okay,
Yes,
so
sir.
I am going to do the second one also with you. Then the last two, I will ask you to give me your various answers. So this one too, okay, your variable has been defined already. So therefore, okay, a number x increased by 6. So obviously my number is x. Increase we know is for what? Addition. So it will be plus what? 6. All correct.
Yes, please.
Yes,
Okay,
sir.
so now I. Okay, I'm going to pause. Send me your answers, okay, via direct message, not a general message, okay, on the Zoom chat. Okay, so let's look at how best you can, okay, do the I. Okay, I now. I'll come to the IV, then we'll come and write the answers together. Okay, so having gone through your various answers, okay, I can see that there is a confusion here. So we are going to negotiate understanding and clear out all, okay, the confusion. And by that, this is what I mean. Okay, so with this one, we said 8 less than a number x. 8 less than a number x. Some of you wrote x minus 8, okay, and okay, others also wrote 8 minus x. So we want to see which is which, because obviously x minus 8 is not the same as what? 8 minus x. Do you get me? Do you agree?
Yes, please.
Yes,
Okay,
please.
Yes,
so
please.
which is which? Okay, and this is what you want to, okay, and I mean, you have to take note of, okay, please take note of this. All right, anytime we say that 8 less than a number x, okay, so it means we have our number x, okay, but it should be 8 what short. Okay, so it means I'm talking about I have my x and I'm subtracting 8 from 8. So 8 less than which 8 less than which number? So 8 less of what? Of x. 8 less of what? Of x. So in this case, the actual answer or the correct answer, okay, will be, okay, x minus what? Minus 8. Okay, if you don't get it, let's negotiate, okay, understanding. And if you are, okay, so you put up your hand if you have issues, and let's negotiate understanding. And here today, that's how we are going to do that. So you are going to argue your case out. If you believe otherwise, I will also argue my case out. Then, okay, the judge will come in and settle, okay, the debate. Okay, don't take anything that I tell you hook, line, and sinker. Yes, it's good. You are supposed to believe in me. You are supposed to trust me. Okay, however, that's you have what brings as well to think. The fact that you trust me doesn't mean if I tell you 1 + 1 is equal to 5, you take it. Okay, you should know that that cannot be the situation. So now let's see. My professors, does that mean you all agree? Okay,
Yes,
Prof.
please.
Enam. But it's not true. You all don't agree because some of you gave me the answer as 8 minus x. Unless maybe what I have said now, okay, you agree.
Mr. Akman, so does it mean that when they say 8 less than a number x, the x is supposed to come before the 8?
Very good. Is that clear? Okay, so now I'm going to put the statement this way too, and let's see how you okay give your what do you call your algebraic expression. A number x less than 8. A number x less than 8. What would that be?
Sir, please, can you come again?
A number x less than 8. Okay, how would you write it?
8 minus x.
8 minus x. So this is it. If you get this, then we can settle the debate now. So anytime you see two quantities, okay, in this case, you can see that we're talking about 8 less than a number x. Okay, proportion, let me land. Okay, I'm making a statement. After that, I will call you. Maybe after the statement, okay, your question wouldn't be relevant. Okay, so I was saying, making a point, and this is a very important statement, so I would want to learn first. Okay, if you read any mathematical, okay, or yes, a statement in terms of English, okay, this is what you need to do. And you see 8 less than a number x. Okay, remember the other one we said, okay, the other one, what did we say? That I mentioned that what? A number, let me write it so that you can relate. A number, okay, x less than, okay, 8, am I right? Let me write the 8 in as a figure. A number x less than what? 8. Okay, so please take note. Okay, remember we said this is what? The same as what? 8 minus what? X. That is the meaning. Okay, so if you study it carefully, you realize that anytime you see this statement, 8 less than a number x, okay, and here is a number, okay, s less than 8. So the quantity that comes after the less than is what must be your first quantity. You know that obviously you are dealing with what? Difference. Okay, so your quantity that comes after the less than is what must automatically be your first quantity. So in this case, 8 less than a number x, less than the number x is what comes after the less than. So that is supposed to give us x minus 8. Is my point well made?
Yes, please.
Okay, and with this one, you can see that a number s less than 8. So the 8 is what comes after the less than. So 8 is supposed to be the first one. You know that the numbers that you are dealing with will be 8 and x. So the first one, if the first one becomes 8, you know the sign is minus. So minus what? Your second one, which is the remaining, okay, number, which is what? X. Okay, Prof. Portia, you can now ask your question. The rest of you, I guess, including Portia, I guess my point is well made.
Yes, please.
So that is the only note, okay, that you need to be, okay, attentive to. Okay, you need to take note of. Okay, Prof. Portia, have I addressed your question?
Please, please no.
No, okay, so go ahead.
You said that for the I, 8 less than a number x, the result will be x minus 8. But for this, the I, that is the 6 times a number x decreased by 4. Why? I want to ask a question. Why did the 6x start first?
Okay, all right. You can see that, listen, you can see that here we are saying that 6 times a number x, so you have to multiply the number by x before you decrease it by 4. So 6 times the
Okay.
number x decreased by 4. Do you get the point?
Yes, please.
So you multiply your x by 6, then after that you reduce it by 4. So that's how come you had a 6x minus what? Minus the 4. Is my point well made?
Yes, please.
Okay, all right. Okay, so I think that one is direct. Now let's come to the IV. Okay, IV, let's see. Therefore, okay, again, our variable has been defined. We are told that, okay, 15 minus 1/3 of a number x. So, you know, as for this one, is obvious. Okay, it's usually the less than one, that one is, that's the one that will be tricky. So that's why I have untied the knot for you. Okay, remove, okay, or demystify how tricky, okay, it will be. So in this case, we said 15 minus 1/3 of a number s. So I have 15, then minus 1/3 of a number s. So 1/3 of a number is 1/3 the number x. Is the point well made?
Yes, please.
Okay, so, all right, Prof. Frank.
Please, for one, just wrote x over 3. That's okay.
Which one?
For IV.
I want IV.
Yes, please.
Yes, you can. It's the same as x over 3, the same. But you should know that it's the same. A over B, okay, is the same as 1 over B times A. So it's the same. Is that okay?
Yes.
All right, so we can write this as x over 3 is the same. Okay, but because we said 1/3, wanted to make the 1/3, okay, clear, and yeah, it's 1/3 of what? X. As simple as that. Okay, so if that's the case, now we are building our point. So usually you have to get your expression before you move into what are the equation that you saw for your unknown. So we are building our, so let's move on to the next one. Okay, so if you don't have issues, I guess I can move on to the second one. Any issues before we move on to the second one? We are even there before I start or we start solving. Okay, we are all fine, we thank God. Okay, so what do we have? We have here represent each using symbol. So it's the same as, okay, write the mathematical expression or algebraic expression form of what you have here. So the sum of two numbers is what? 15. So when you see sum, we are talking about what?
Addition.
Hello, we are talking of addition.
Addition.
Okay, so the sum of two numbers is what? Is 15. So please take note. So in this case, you can see that unlike the other one, where the numbers were already defined with the letter X, here no definition. So this is how we are going to proceed. Okay, so we will let our number be equal to what? X. So solution to question 2, question 2I. Okay, we will have to represent the unknown by what? A variable. So you will let, okay, x be equal to your number. Okay, so maybe we are the sum of two numbers. So let's talk about the first number. Is that clear? Point well made, my
Yes,
professors.
yes, please.
Okay, so you can also say that let y be equal to your second number. Okay, however, if you introduce another letter, then it means if you are going to form your equation will involve two letters. But don't worry, we'll break it down to only one letter. So I'm going to write this. Please take note. So I'll write, okay, and what? Y also be equal to what? The second number. I will break it down for you too. So don't write yet, those of you who would want to write. In any case, I will give you the PowerPoint, okay, PDF version of that. Okay, so this is the case. So it means indirectly, we are told that the sum of these two numbers should give us what? 15. So I can say that this implies that my first number, which is x, plus my second number, which is what? Y, should be equal to what? 15. Is that clear? Is that clear?
Yes.
Yes,
Okay,
please.
very
Yes,
good.
please.
Now, from the first, okay, I mean the statement that we have here, you can obviously see that, okay, we can express y in terms of x. So that it means we'll be dealing with only one what variable. In that case, you don't have to generate two equations to solve for two unknowns. You only have to generate one equation. Okay, if you express one of the variables in terms of the other, usually you form one equation. But if you don't, you have two unknowns, and two unknowns, before you can solve for two unknowns, you have to get at least two equations. So in this case, indirectly, I can say that my y here is equal to, okay, 15 minus x. Do you agree?
Yes, please.
Okay, so in this situation, someone can also write this, the statement, okay, as this. Okay, take note of that. We said the first number will be x, so therefore the second number will be what? 15 minus x. Because if I add the two, I should get 15. Is that clear?
Yes, sir.
Okay, so someone can also write it that way. Okay, so take note of that. Okay, so this one, y has been expressed in terms of what? X. Okay, all right. So now, if that's the case, I guess I can move on to II. So II, so this is what we have. So indirectly, this is the statement. Okay, this is it. Okay, x plus y is equal to 15. But I said we can write it this way. Okay, as well. Okay, so now let's go to II. Okay, II, let's break it down. Always break it down. When you break it down, you know. So the first one, okay, number is 6 more than twice the other number. Okay, so, okay, this is what we are going to do. Okay, we are saying that between the two numbers, one will be bigger, one will be a smaller number. Is that not it? My professors, are you with me?
Yes, please.
Okay, very good. I want you to talk. Okay, I've told you that this is one of the challenging topics. So ask questions, contribute, and let's make the class interactive just to, okay, help shape our understanding. So one number is so small, okay, than twice the other number. So we can you can see that the two numbers, okay, one will be bigger, one will be smaller. Okay, so if you like, you can use first number, second number, or okay, bigger number, smaller number. Is that clear? So I will
Yes,
Yes.
please.
again write okay, okay, x be equal to what? Okay, the first number. Okay, so now if that's the case, let's go and look at the relationship. Said one number is 6 more than twice the other number. So we are going to let y be equal to the other number. Is my point well made?
Yes,
Yes.
please.
Okay, so if that is the case, we are saying that one number is 6 more than twice the other number. Okay, so it means here, my first number that I have here, if I say that it is what? 6 more than twice the other number, how am I going to write it? My professors, okay, I don't want to be like I'm spoon feeding you, so let's all contribute. How are you going to write it? Prof. Gideon.
So this will be 6 plus x plus
6 plus,
2y.
6 plus x. Come again, 6 plus x plus 2y.
Yes, sir.
Oh, really? Okay, you have tried. Let's see. Okay, Prof, yeah or Popia? So, Prof, yeah or Popia? I'm waiting for your answer. So, what will y be equal to if y is the other number?
Um,
That is the second number. If I need to put it that way. Okay, so let me use first and second for you to even relate better. Prof. Giovanni, let me use first and second. So I'm going to clear that. Okay, and represent that by your second number. Then we go and get the relation. Okay, so second number. Prof. Giovanni, let's go.
Please, the y will be equal to 2y.
Y will be equal to 2y.
Yes, please.
Okay, so what happened to the 6?
The 6 will be added to x. So it will be x plus 6. Then y will be 2y.
Okay, you've tried. Okay, that's okay. Very good. We'll negotiate understanding. You've tried. That's okay. I like that. Okay, Yapopi, your hand is still up. Okay, Gideon, have I
Sir,
called
please,
you?
it's going
Yapopi, your hand is still up. You want to change your answer?
sir, please, I didn't speak for the first time. It's x is equal to 6 plus 2y.
X is equal to 6 plus 2y.
Yes, sir.
Okay, all right. Not a bad try. Okay, Prof. Gideon, is your hand up?
Yes, sir.
Uh-huh.
Please, x will be equal to 6 plus 2y.
X will be equal to 6 plus 2y. Okay, all right, not bad. You are doing well. Okay, keep it up. Okay, so let's see, Prof. Caroline.
Sir, please. I also got 6 plus 6. X is equal to 6 plus 2y.
6 plus was 2y. Okay, all right. So not bad.
Um,
But it
sir,
seems
please,
somebody wants to say something.
it's x is equal to 2y plus 6.
2y plus 6. Okay, because
Yes,
addition is
sir.
commutative, okay, it is not different from what the other said. Okay, the other one, there will be difference because x minus 8 is not the same as 8 minus 6 because subtraction is not commutative. So you have to specifically know the one that we are dealing with. But with this one, if you swap, there wouldn't be any issues in terms of the addition. Is that clear? So it's
Yes,
not
please.
different. Okay. All right. Interesting. So I'm going to write something. If you disagree with me, okay, then you tell me. If you agree, then okay, we'll see how best maybe you can help me with the explanation, okay, or okay, we can okay deal with it in terms of okay our understanding. So I am going to write this. So can I say that my y okay here will be equal to 6. Let me, so it says 6, okay, plus 2x. I guess you are thinking through. My professors,
say,
That man.
yes, please. Are you thinking through, my professors, to see whether you agree with me or otherwise?
Yes, we.
Okay. Prof. Enam.
Sir, please, the question said one number is more than twice the other. So how do you know that the one number is y and then the other is for x?
Okay, so that's why I said you are going to carry out your representation. Is that not it?
Yes.
Okay, so you are, and I've told you that usually, okay, for me, because I always want to work with only one variable, okay, I only introduce the y here for you to easily relate in terms of the explanation. Okay, otherwise with this one, I will say that my first number is x and my second number is what, 15 minus x. Okay, I will never involve y. You get my point? But I had to go this route for you to appreciate how I got my second number to be 15 minus x. You get the point?
Yes.
So it's the same direction that I want us to go here. So if your first number is x, okay, then your second number, remember we said that the number that you are thinking of, which is supposed to be your second number, it has a connection with your number that you have picked. And the connection is that, so let's assume, okay, the number that we don't know is x. Okay, if the number that we don't know is x, then the other number, the y, that you don't know, now indirectly you know, but you know it in terms of x because it's connected to x. Is that not it? Should I come again, my professors?
Yes, sir.
Okay, remember we are looking at two unknowns, but the two unknowns, they are related. So if I know one, I can connect. If I know your parents, okay, I can connect. I can get the relationship. Okay, that's exactly the point. So here, if my two numbers, okay, one of them is y, one of them is x, one is y. So I'm assuming that the number that I don't know, okay, is x. So if the number that I don't know is x, then indirectly the other number I know, but I will know it in terms of x because it's connected to x. You get my point?
Yes,
Because
please.
you can see that that's what I did here. The first number is x. So the number that I don't know is x. So if I don't know x, I know y because y will also be expressed in terms of x because y and x are connected because I've been given the connection here. In the same way, you've been given the connection here. Okay, so the number that you don't know is x, but the second number that you don't know is y, but the y is connected to x. So it means, okay, because you know that the number that you don't know, you've represented it by x, y is also known, and that will also be in terms of x. But how will be the expression for the x? And that will come from the relationship given here. So if my unknown, okay, is x, then it means the number that I'm looking for, remember I know is connected to that x. And we said it's 1, okay, so that is my number that I'm looking for will be 6 more than twice the other number. So the other number is indirectly what I have represented by x. I hope you get my point. My professors, are you with me? Or I should come again?
Yes, please.
Yes,
Please come again.
please come again.
Okay, don't worry. Okay, remember I'm here. So let me see how best I can break it down. Okay, so in terms of, so assuming maybe this is it. I'm looking for two numbers. One is x, one is y. So two numbers, basically. Okay, so if I know my first number to be x, I know the x is connected to y. Okay, so what is the connection? The connection is that my number that I'm looking for, okay, is supposed to be, okay, which is the one number, the one, you know the relationship. Okay, the number that I'm looking for is supposed to be 6 more than twice the other number. 6 more than twice the other number. So the other number, okay, let me take this, the unknown to be my other number, the known to be y. Y is the known because y is connected to the unknown. You get the point?
No, please.
Okay, so this is it. Okay, if I tell you that I'm looking for two numbers whose sum should give me 15, and I give you one number to be 5, don't you know the other number?
Yes,
The
please.
other number will be what?
10.
10. So because you fixed the first number to be 5, the other number which initially was unknown, you know it because of the relationship. You get my point?
Yes, please.
Please, are you getting my drift here? The direction of my argument now. My professors, are you there?
Yes,
Yes.
please.
Okay, are you getting the direction? If you know, I've given you two numbers, you don't know them. But I've told you that the two numbers, if you sum, you are going to, let's say I said x plus y should give you what, maybe 15. But once I give you the first one of the numbers, so if I tell you that if x is equal to 5, what will be the value of y? You will know, okay, your y, because you know the relationship between x and y. Is that not it?
Yes,
Yes.
please.
And so that's exactly my point. Though these two, x and y, are not known. Once one is known, the other is known. You get it?
Yes,
So
please.
if I
Yes.
know that this is x, then I know the other because I know that the other one will be connected to what x, but it will be connected with this relationship that I have here. So I know that y will be 6 because y is what I'm looking for. It will be 6 more than twice the other number. So the other number that I don't know is what, x. I hope you are with me. So it means y will be equal to, okay, 6 plus 2, the other number, and the other number is x, 2x. Should I come again? Prof. Josephine, your hand was up. I intentionally wanted to align, so forgive me, okay? Okay, you can come in now.
Sir, please, I was asking, so you're saying it can also be x equals 6 plus 2y.
Okay, if you write x is equal to 6 plus 2y, there is nothing wrong with that. It's the same. Only that you are looking at what? Your unknown. Okay, that's your first unknown to be your y. So in that case, x will be expressed in terms of y. You get my point?
Yes, please.
So I use this because, okay, I'm saying once I say y is equal to this, you will say that x is equal to 6 plus 2y. There's nothing wrong with that. It's the same thing. Only that if I write it this way, then it means my first unknown, which is the other number, is x. For you, if you write it x is equal to your other number will be y. You get it?
Yes, please.
Please, are we all fine now?
Okay.
So
Yes.
someone, if you write this, you are not wrong. If you come and write x is equal to, okay, 6 plus 2y, you are not wrong. So you are taking your other number, which is your first number, to be y. So that your second number will be x, which will be equal to this. There's nothing wrong with that. It's the same. Only that we have changed the variables, but it's the same. We have changed the source, but it's the same. The naming of the source. Okay, Prof. Informer.
Mr. Akman, please, how is y the, you said that if x is equal to 6 plus 2y, then y is the number and then the x is the other.
No, I said if you write it this way, then it means y will be the other because we said twice the other.
Okay.
You get it?
Yes, please.
And in this case, what I wrote, I am taking s as the other number. You get it? So indirectly, my first number that I have here is the other number, sort of. Afa. Hello,
Yes,
my
Prof.
professors. We are building, we know the way I arrange my questions. So if you don't get it here, you wouldn't be able to appreciate whatever we will do next. So please make sure you come on board if you are not on board. So ask all the necessary questions. I've told you this topic, that's how it is. Okay, so now let's move on to the III. Okay, one number is 4 less than. Okay, and here you can see that our whatever that we were talking about is in play now. So I expect you to give me the right thing. So it's 4 less than 1/2, okay, another what number. One number is 4 less than, okay, 1/2 another what number. Okay, so in this case, it will be the same as the other one. Which one you take as the other number and which one is you are supposed to take as what's your number that you are looking for. Is my point well made?
Yes,
Yes,
Okay,
please.
so this is how I am going to deal with this one for everyone to appreciate. So there I will represent my first letter or my letter to, I will use X to represent the other number. Is that clear?
Yes, sir.
Okay, or another number is the same thing. Okay, so in that case, that will go. Please ask all your questions. So I've told you. All right. Okay, so word problem usually, okay, I consider that as a low hanging, okay, what do you call it? Question. Okay, it's usually very easy once you are able to untie the knot. Okay, so I will let, okay, I didn't normal, that is I. Okay, we will let maybe X be equal to what? Okay, the other number. Okay, so in this case, then it means the number that I'm looking for, if I label it as Y, okay, so it means my Y, this implies that my Y, which is the number that I'm looking for, let's go and get it what? So Y indirectly is the number that I'm looking for, not the other number. Is that okay? The number whose relationship with the other number is known. I hope you are with me.
Yes, sir.
Okay,
Yes,
so
please.
indirectly, let me write it this way. I think I'm moving at a rate that, okay, if I don't take care, I will confuse you. So in this case, let me go and pick. So it means Y will be the number itself, not the other number. The number. So it's the number and the other number. Do you agree now?
Yes, sir.
Okay, so now broken down to your level for you to appreciate. Okay, so at this point, then it means the number that I'm looking for, you know it has a connection with the other number. So that will be equal to. So let's go and get the connection. Remember, we are told, okay, the connection is that, okay, one number is 4 and one number, the number that is what I have here, is 4 less than 1/2 the other number. Okay, so already we have 1/2 the other number, so it will be half of the number, which is the other number, which is X. Is that clear? I hope you are with me.
Yes, please.
And the other quantity that I have here is 4, just like the other one. But we want to know whether it will be 4 minus this or this minus 4, just as we saw in the first one. So here, there shouldn't be any confusion. My professors, are you with me?
Yes, please.
Okay, so in this case, which one will come first? Is it the half, okay, S or the 4? Per the advice that you've been given.
Half X.
Half
So
X,
please,
perfect. So it means you've gotten exactly what I said. Because remember I told you that the quantity that comes after the less than is what you must write first. So what we have here will be half, okay, X minus 4. All correct, my professors?
Yes.
yes,
Sure.
sir.
Are we all fine? Who wants me to come again, my professors? Okay, possible Augustine. Where exactly should I locate you?
Sir, please let S equal to the other number. That part.
This one.
So,
Okay,
yes.
so we are looking for 2 numbers, is that not it?
Yes, sir.
If you like, you can say X be the first number, okay, then Y be the second number, no issues. But you know that you are dealing with 2 numbers. And one is connected, okay, to the other. So if the first one is what we have represented by X, then it means Y will also, you can express Y in terms of X because Y is connected to X. Is my point well made?
No, sir.
Oh, the relationship that we have here, we said one number was 6 more than twice the other number. So how many numbers are we dealing with? How many numbers?
Sir, please 2.
2 numbers, is that not it? And the
Yes,
2
sir.
numbers, if you know one, whether the one is what known specifically as a value, or known as a what? As a variable. We know the other. So if the one is known as a value, then it means the other one will equally be known as a value. If one is known as a variable, then the other one will also be known as a variable because the connection is with a variable. You get the point?
Yes, sir.
So if you represent the other number by x, okay, because you look at what you have here, you said another number, okay, another number. So either this is the other number or this is the number, irrespective of how you are looking at it. But I said because of the connection here, one have another number. So let the another number or the other number be what? Your x. Is that clear?
Yes, sir.
So that I can get, okay, 1/2 of what the other number to be 1/2x. Is that clear?
Yes, sir.
Okay, but 1/2x, remember we said the number that you are looking for. So now it means the number that I'm talking about is y. But that number, what is the connection? The connection is that, okay, is 4 less than 1/2 the other number. So it will be equal to, okay, 1/2 the other number minus 4. And 1/2 the other number is x minus 4. You get it now?
Yes, sir. Thank you very much.
Okay, you are welcome. Okay, so it is now possible. Initially, it was impossible. All right. So now let's look at what we have here. So we are done with what? I. So let's look at IV. If you are all fine, we can move on to IV. IV, what do we have? Okay, so 3 times a number increased by 10 is equal to 20. Okay, 3 times a number increased by 10 is equal to 20. So here you can see that we are more or less moving on to an equation because usually you form an equation then what you solve. Okay, but no issues. Let's see how we can. Every equation will contain an expression. So now let's see. 3 times a number increased by 10 is equal to what? 28. So we don't know the number. So represent the number by x. Is that clear?
Yes, please.
So let x be equal to what? Okay, the number. My professors, are you there? So let me clear what
Yes,
we have
please.
there. It has served its purpose. Okay, quickly. Let's go. All right. Oops. Okay, number. Okay, so if x is the number, then we are going to say that if you look at the statement here, it said 3 times a number increased by 10. Okay, so it means this is what I have. So this implies that 3 times the number will be 3x. Is that clear?
Yes, please.
Professors, are you with? Increase by is for which operation?
Yes.
Increase by
Addition.
is addition. So plus, okay, increase by what? 10. And remember we said whenever you see is or you see is equal, we are talking of which what sign? Let's
The
go.
equal.
The equal to sign. So it means this is equal to what? Is equal to 28. Is it clear now?
Yes, please.
Yes.
Who wants me to come again, my professors? Okay, if you get this, the next question will be easy because the next question will form this, then we move on to find our x. Okay, all right. So now let's go and look at what the V, and the V will be yours. So I think let me pause here and okay, I want you to give me the once you see it's equal to it means you are going to form an equation. Okay, so let's see how you'll be able to form this equation for me. Send me your answers, okay, via okay PME, private message me on the Zoom chat. Okay, please, I'm waiting. Let me pause and see whether okay there are issues. Okay, so having gone through your various submissions, okay, your answers that you gave me, okay, I know where the issues are. So we are going to do it together. Okay, those of you who had it right, you pat yourself at the back. Those who didn't get it right, no issues. Take note of where the issues are. Okay, provided you are able to follow my explanation. Okay, if not, ask questions so that I will further explain for you to get why I have this, okay, solution, okay, that I'm here to write. So now let's go and look at how best to carry out our presentation for the VIN. Okay, so VIN, okay, we don't know the number, so we represent the number by X. So we are told the difference between a number and 1/2 itself is equal to 12. So let the number be X. So X be equal to what? The number. Okay, or the number be equal to X. Is that clear?
Yes, sir.
Yes,
Okay,
please.
so if X is the number, remember, let's look at the relationship here. He said the difference between the number, so this is the number. Okay, and 1/2 itself. So 1/2 itself is referring to the number. Okay, is what is, okay, 12. So the number itself is X. Okay, oh, where is my, I can't find my, okay, I think, okay. The number itself is X. Okay, 1/2 the number, okay, is what? Half of X. Is that clear?
Yes, sir.
Okay, so here we are told, so I will say that this implies, okay, that we are told that the difference between the number and what 1/2 itself is what? Is, what do you call it? 12. So the difference I'm talking about, okay, this minus that. So I'm going to get X, okay, minus half, okay, let me write X minus half X, okay, should be equal to what? 12. Okay. Any issues? Okay, obviously it cannot be half X minus X. Please take note. So anytime we say the difference between A and B, it will always be A minus B. The difference between B and A will be B minus A. Is my point well made?
Yes, please.
Yes, sir.
Okay, all right. Prof. Caroline.
Mr. Hackman, please, I thought if, like, the way they've written it in the statement and said, please, I thought, like, the number after it, how can I say? Like, they wrote the difference between a number and 1/2 itself. So I wrote half, like, X minus X is equal to 12. I
Okay,
thought, like,
so
if you write X minus X, that part is correct.
no, so that's why I said, I just explained that. Okay, it cannot be half X minus X. Okay, because you are told that you are talking about the difference between a number and one. So whenever we say the difference between a number, so let's say a difference between A and B. So if I say the difference between A and what? And B. Okay, that will always be A minus B. So it will always be your first minus the second. The difference between B and what? A will be B minus A. Is that clear?
Yes, please.
Okay, so it means indirectly, if I should put it this way, okay, the quantity that comes directly after your difference, okay, or yes, first after your difference is what must be written first. Okay, then your minus the other one. You get the point?
Yes, please.
Okay, so that's the issue. So I knew some of you wrote the half X minus. So that's why I explained. Okay, the difference between A and B is A minus B. The difference between X and Y is X minus Y. The difference between Z and W is Z minus W. The difference between W and Z is W minus Z. You get it? Are we all fine now?
Yes, please.
Okay, so Prof. Josephine.
Sir, please, because they said 1/2 itself, so I thought it was like 1/2 alone without the X. So
Okay.
I don't understand how.
No, it said 1/2 itself. The itself is referring to what? You always take, okay, 1/2 of something. So if you say 1/2 of itself, then it means 1/2 of the number that you get it, and the number is X. So I didn't say the difference between a number and 1/2 is what do you call it, equal to 12. I said 1/2 itself. So 1/2 of a quantity, and that quantity is itself, and itself is what? The x. You get it? Because that's the number.
Yes, please.
Do you
Thank
get it
you.
now?
Yes, please.
All right, okay. So on that note, I think, okay, we've done about an hour. You can have your water break. Let me pause. When you come back, then we resume. Okay, so you are welcome back from the water break. Let's look at our next worked example. All right. Okay, so worked example number 3, write an equation for each of the following. So we need to, okay, give the equation form of what we have here. Just the equation. We don't go beyond the equation. Okay, so question 3, solution. Oops, let me go back. Okay, question 3. Okay, then A. So here, write an equation. So we are writing only the equation. Okay, take note, you underline that before you go back and do what, okay, you've not been asked to do. Okay, so let's read the statement. One number is 10 more than another number, and their sum is what, 16. So it means we are dealing with how many numbers here? Hello, how many numbers are we looking at? My professors, how many numbers? Are you there? Can you hear me?
Yes, please.
How many numbers are we looking at in the first statement that we have here? The first part.
Sir, 3.
please 2.
2 numbers. Okay, 2. 2 numbers. So you represent what? The first number by what? By x. So if you look at what we have here, obviously you know we are going to write we have 2 numbers. Okay, okay, x be equal to what? Our first number. Okay, so if x is equal to the first number, then obviously you know the second number because of what? The connection, okay, of the second number with what? That of what? The x, your first number. Because we are told that one number is 10 more than the other number. Okay, so it means my other number will be 10 more than x. Is that clear? That is if x is my smaller number. Is my point well made?
Yes, please.
Yes,
Please, my professors, are you with me? Are you following?
Yes, please.
Okay, so in this case, I don't want to introduce y. So I will say that this implies that, okay, x plus 10, okay, will be equal to what? Okay, my second number or other number if I like. Okay, however, okay, but I have been told that if I sum these 2 numbers, okay, my result should be what? 16. Is that not it? My professors, are you with me?
yes, please.
Okay, so it means I'm
Yes,
going to
please.
get my first number, which is x, plus my second number, which is x, plus what? 10. Okay, should give me what? 16. Afa.
Yes, please.
Okay, so indirectly, that is what? The equation. So in this case, okay, if you like, I can write, I could have put therefore here. Okay, otherwise I'll come and write therefore, then get 2x plus 10 is equal to what? 16. I would advise you conclude with this so that it will be direct. Your first plus your second is equal to 16. It's my point well made. So let me also do that. Okay, so that you can relate. Okay, so the next one, when I'm forming my equation, I will conclude, okay, there straight away. So let me do the needful. Okay, so we're just asked to write the equation, that's all. Okay, that's not to say that if you write 2x plus 10, you'll be marked wrong. Please, no, it's the same. Okay, so therefore, x plus 10, okay, is equal to 16 is the equation. Okay, Prof. Frank.
Sir, please, I don't understand how the x plus 10 is the second number.
Oh, so you know 2 numbers. Okay, 1 is bigger than, okay, 1. But 1 is 10, okay, more bigger. Okay, or in this case, so this is what we said. One number is 10 more than the other number. Okay, so it means I have two numbers. One is small, one is what? Big. Is that okay?
Yes, sir.
Okay, so if I represent my small number, which is the first number by x, then indirectly I know my second number because my second number is supposed to be, which is the bigger number, is supposed to be 10 more than my first number. So it means my second number will be s plus 10. If I know my first number, I know my second number. How do I get it? By adding 10. Okay, in that case, your second number is bigger than what? Your first number. Is that clear?
Sir, so does that mean that the 10 more than another number will be the same as 10 more than the same number?
Oh, so like the way we started, we are building, it seems you are not, then it means you are not following. Remember, I've told you that if you know one of the quantities, okay, you know the other because the other will be expressed in terms of the first one. So if I know that my quantity is x, then the other one I will express it as what? Even if I call this one y will be expressed in terms of x because y is connected to x. So it means y will be equal to my first number plus what? 10. Is that not it?
Yes, sir.
But I didn't want to introduce y. Okay, because you know from there we have gone beyond. So in this case, instead of writing y is equal to the second number and come and write equal to, then y will be, okay, 10 plus x or s plus 10, which is the same. Then I'll come in, and before I'll come and form this, I know that my y is always connected to my x. So if I know x, I know y in terms of x. You get it?
Yes, sir.
So if I know that my number is x and I'm told that the other number is 10 more than, okay, the other number, okay, or the 10 more than the number, then I'm going to get it. So if you like the way you started, you could have represented the x by your other number or another number so that you know that your y will be what? S plus 10. That is 10 more than the other number. I is the same, just as I explained earlier. Point well made.
Yes, sir.
Okay, so if that's the case, then we can move on to B if you don't have any, okay, issues. So let's look at the B. The B, what do we have? Okay, the smaller number is half of the larger number. Okay, so it means here, how many numbers are we dealing with? How many numbers? Two numbers, right?
Two.
One being a
Yes, sir.
smaller number and one being a larger number. Is that clear?
Yes, sir.
My professors, are you there?
Yes, please. Yes, please.
Okay.
Yes, please.
So if you have this, then it means our work is going to be very easy. Okay, so you have two numbers. With this one, you can be more specific in your representation because the two numbers are classified smaller and what and larger. So instead, you don't use first and second. You use smaller number and larger number. Is that clear?
Yes, please.
Okay, so in this case, I am going to write, okay, so let me write, okay, because the smaller number is expressed in terms of the larger number. Okay, because the relationship, that's what you have. You can say that I said the smaller number is half of the larger number. So the smaller number is expressed in terms of the larger number. I am going to represent, okay, my larger number by x. So x will be equal to my larger number. Is my point well made?
Yes, please.
Okay.
Yes, please.
Okay, so this implies that my second number, okay, which is a smaller number, okay, will be, remember we said it will be half of the larger number. So it means half of the larger number, which is half of x, will be equal to my smaller number. Is that clear? My professor, should I come again or my point is well made?
Yes, please come
Sir,
again.
please come again.
Okay, all right. Okay, so the word problem, okay, is becoming a problem. All right, no problem. Okay, we'll get there. So this is it. We said we are looking at two numbers, a smaller number and a bigger number, is that not it? Or smaller number and a larger number. So if I represent my larger number by x, indirectly I know my bigger number, because in this statement, I've been told that my smaller number is half of the larger number. So if the larger number is x, my smaller number will be half of x. That's what I have here. You get it?
Yes, please.
Please, those of you said I should come again. Are you fine now?
Yes, please.
Okay, so indirectly, it means my bigger number is twice. If I represented my smaller number by x, sorry, my, my smaller number by x, then my bigger number will be 2x. Do you get it? If, let's say, the two of us, assuming your age is 30, okay, or let's say 15, and my age is 30. Okay, so if I have a bigger age, okay, I am older than you, and if I represent my age by x, if you want to get the smaller age, okay, you can see that my age is more or less twice yours. So if you want to get the smaller age, you don't multiply it by 2, but you rather divide by 2. I hope you get my point.
Yes, sir.
And in the same way, if I know the smaller age and I want to get the bigger age, okay, I have to multiply the smaller age by 2. If I know the bigger age and I want to get the smaller age, okay, I have to divide it by 2. Point well made.
Yes,
So
please.
this shows you cannot call this, please take note, you cannot say that s is equal to the smaller number and come and write half s is equal to the larger number. Obviously, it would not make sense. How can okay, x, okay, and half x or half s be larger than x? It doesn't make sense. You get the point?
Yes, sir.
Okay, so that's exactly. So now that we know the numbers, we are going to form our equation. So I'm going to form the equation, then we'll look at what the solution together. Okay, so quickly let's form the equation together. Okay, give me some few seconds. Let me answer this call. Okay, so let's go. Okay, so thanks for your patience. Okay, so now we can form the equation knowing the two numbers because we know, the equation here. So we said the sum of the two numbers will be 36. So it means these are the two numbers, you know them now. Okay, and they are all in terms of s. So you generate one equation in one variable. So you are going to get the sum of the two numbers. So your first number is x. Okay, oops, my x is not x. Well, all right. So let me write it well. Okay, so x, plus what? Half x, should be equal to what? We are told the sum will be what? 36. Is that clear?
Yes, please.
Okay, so this then becomes the equation. Usually, you'll be asked to find the number, so that means you have to proceed and solve for your x. But how do you solve for your x if you are unable to form the equation? So that's the more reason why I have, more or less separated how to form the equation, from how to find or solve for your equation. Because the main thing is get the equation formed right before you can, deal with it. Okay, so now the last one, the C. Okay, all right, see, what are we looking at? A certain number exceeds, another by 6. Okay, so again, how many numbers are we dealing with? Two numbers, is that not it? And once we are saying that one number exceeds the other by 6, then it means we have a smaller number and a bigger number. Is that clear?
Yes, sir.
Okay, so in this case, you can call the smaller number your first number, and your bigger number your second number, or still label them as let s be the smaller number, and in that case, your bigger number will be your s plus 6. Is that clear? My professors, are you with me?
Yes, please.
Okay, so now let's proceed and put whatever that we have there into writing. So let's, x be equal to which number? The smaller number. Is that not it? Okay, so smaller number. Okay, so this will imply that if x is a smaller number, then our bigger number, remember we said the other number, which is the bigger number, exceeds the smaller number by 6. So remember we told whenever you see exceeds, we are talking of what? Addition. So it will be x plus 6 will be equal to what? The larger number. Point well made.
Yes, please.
Yes, sir.
Okay, but you know that the sum of these two numbers will give you 56. So I will say that therefore, my first number, which is x, plus my second number, which is x plus 6, okay, should be equal to what? 56. Apa, is that correct? Hope we are all fine, my professors.
Yes, please.
Okay, all right. So on this note, we are done with this. Okay, any questions before we go and look at what? Where we'll be asked to find the numbers. My professors, are we all fine?
Yes, sir.
Yes, please.
Very good. So now ask all the questions. So, okay, word problem, whether you get it, I mean, you like it or not, you will see then. Okay, plenty in your exams. Okay, always a lot, I should say. All right, so now let's look at how to solve number problems. Okay, so first step, represent an unknown by using a variable, say x. So that one we know. So indirectly, what we have here, we have done it. Okay, okay, and the last one. So now let's see. 2, the second step, if necessary, represent the other unknown or unknowns. Okay, by using algebraic expression in terms of x. So remember we said the other unknown, which should have been y. Okay, I said you have to express it in terms of your first unknown. Okay, so that you generate only one equation and you use it to solve. Okay, so that's what the second step is talking about. So you represent an unknown by x, which is one of your unknowns. The other unknown, sometimes you have only one unknown, you have two unknowns, other two unknowns. That's what I mean. Okay, so if you have one unknown and one other unknown, the other unknown, you express it in terms of what? Your first unknown that you have represented it by a variable. So in terms of the same variable. If you have two other unknowns, then you express these two other unknowns also in terms of your first unknown that you have represented by a variable. So that's the meaning of this statement. Then from the conditions of the problem, write an equation, which we know how to do that. How to do now. Write an equation using the algebraic expression, okay, representation of the unknowns. Okay, I think there is something missing. Okay, I should have added and solved the resultant equation for your unknowns. So let me quickly pause and do that, add that before I forget and send you your, what do you call it, your slides, which will not contain that. So give me some few seconds for me to do that. Okay, so I've added the last, okay, and the very important step. Okay, after forming your equation, you don't end there. Okay, please, last but not the least, you solve the resultant equation, okay, for the unknown. In this case, okay, your equation will be in x, so the unknown will be x, so i.e. x. Then you draw your conclusion. Okay, with it, as simple as that. Is my point well made, my professors?
Yes, please.
Okay, so now let's go and see how best we can, okay, use the steps here to deal with the following, okay, question. All right, okay, so this will be maybe possibly our, okay, last example for the day. So let's look at the first word example. So 2, and we are dealing with what? Word problems involving numbers. Okay, so how to solve, okay, questions like that. So let's see question. Did I write 2? What is happening? I've started exhibiting symptoms. All right, okay, so this will give us 1, okay, rather. So 1A. Okay, at that point I will be doomed if I number my questions wrongly. So, okay, let's see. One number is 10 more than another number, and their sum is 16. So you can see that indirectly we have done this. Okay, so I took only this part of the question for the previous one, then, okay, I didn't add that. So find the numbers will be where you find your x. Okay, so in this case, what do? We are going to, okay, we said two numbers, one, so maybe the smaller number. So x be equal to the smaller number. My professors, are you there? Remember, we have done this. I could have even done copy and paste. Okay, I've already explained this. So this implies that your bigger number, which is the other number, will be x. Okay, because we said it exceeds it by what? By 10. It's 10 more than. So it will be x plus 10. Okay, that will be your larger number. Is that clear?
Yes, please.
Okay, and please, you can see that so far I've not written number this way. Avoid doing that unless you see it in the question itself. This is not universally accepted. So at this point, once I know this, I'm told that the sum is 16. So I'll write but, okay, I'm told that the sum will be 16. So x plus 10, the sum of the two numbers should give me what? 16. So it means I can now solve for x. So this implies that I will get 2x plus 10, okay, is equal to 16. So I will get 2x to be equal to 16 minus 10, which will give me 6. I write it again before I divide. So over 2 over 2. So I will get x to be equal to what? 3. Is my point well made?
Yes, please.
Okay,
Yes, please.
however, I cannot just say that therefore s is equal to 3. Remember, the question says I should find the numbers. So I know the numbers in terms of x. So if I'm able to get s, then I know the exact numbers. Okay, so I'll write therefore, okay, my smaller number is equal to what? Okay, 3. Okay, and my larger number. Okay, I didn't write the number, please. You are supposed to write the number. Okay, my larger number, okay, will be equal to, remember it will be, okay, 3 plus 10, and that will be 13. Afa. Okay, so let me write it for the purposes of explanation. Okay, in terms of what, but I did it mentally. You can also do that mentally. So that will give us 3 plus 10. Let me write it. The next one, then I can ignore. This being the first one. So it will be my x plus 10. So 3 plus 10, which will be equal to what? 13. Is that clear?
Yes, sir.
Yes, please.
Okay, very good. So that will be it for question, okay, A. Okay, so let's quickly look at that of the B. Okay, then if time allows, we'll look at the C and we'll be out of here. All right, so now what do we have? Let me go and clear what I have there to create, okay, a little more room for my next question. So B, we've already formed the equation we know. Okay, a smaller number is half of a larger number. So in this case, we will let, like we did previously, okay, x be equal to the smaller number. Okay, so if x is the smaller number, then this implies that you are told that the bigger number, okay, how do you get the bigger number? The bigger number is supposed to be, okay, is it 2x? So I was expecting you to tell me that, Mr. Ackman, you advised me or you advised us that because the connection is between, and you can see, okay, this, the larger number, why don't we represent the larger number rather by what? The x, so that we'll get the half of the x straight away. But no issues. If you do that, let's see what will happen. Okay, please take notes. Let's see, assuming I represented the smaller number by x. Okay, then it means my bigger number, if my smaller number is half of what? The larger number, then it means my larger number will be what? Twice the smaller number. Do you agree?
Yes, sir.
My professors, are you with me?
Yes, please.
Okay, however, I will go the usual route, then ask you to go the other route and see whether we end up getting the same results. Okay, so on that note, I'm going to, okay, clear this, then write, okay, larger number there, just to conform with what we initially started with. So larger, okay, number. So in this case, this implies that half of x, that is half of my larger number will be equal to my smaller number. All correct, my professors?
Yes, please.
Okay, very good. Okay, so then I'll write, but now I'm going to form the equation. I'm told that the sum will give me 36. So I'm going to get, okay, my x plus 1 over 2x, okay, should be equal to what? 36. So in this case, what do I get? I clear the fraction. So this side contains more than a term. So it's not necessary for me to show the multiplication by the LCM. So I can do it mentally. So it will be 2 times, okay, x, and that will give me 2. So this implies that 2x, then plus 2 times half x, the 2 will cancel, so I will get x. Okay, is equal to the 2 times 36, and that will give us, and that will give us
72.
72. Okay, so now you get 3x is equal to 72. Okay, you write it again before you divide. Don't forget this. Okay, so 3x is equal to 72 over 3 over 3. So I'm waiting for your answer. So x will be equal to, my professors, we shouldn't waste time here. Oh,
24.
24.
24. Very good. So 24. Okay, so now that we know x, it means we know the smaller number, sorry, the larger number, and therefore we are able to get the smaller number because the larger number is what's represented by x. So I'll write therefore because I was asked to find the numbers. Okay, this is just, okay, what I introduce and I cannot conclude with it. So I can't say therefore x is equal to. Okay, so in this case, I'm going to write therefore my larger number, okay, we know is equal to x, and that is equal to 24. Okay, and okay, your smaller number, okay, will be equal to half of what? X, and that will be equal to, okay, half of 24, and that is 12. Is that clear?
Yes, please.
Okay, so if you like, you can write half of 24, okay, here. Okay, is equal to, or half of x is equal to half of 24 is equal to 12. Is that clear? But you can do it mentally. I would have written larger number is equal to 24 straight away, smaller number is equal to, I will do the calculation maybe as a rough work, either mentally or so, then I'll write equal to then 12 straight away. I won't, okay, write the whole of that there. Afa, my professors.
Yes, please.
Okay, so on that note, I believe we will be able to do the C because indirectly we generated the equation for the C. Okay, that is what is here. So you solve this one for your, okay, X, then you draw your conclusion because you were asked to find the numbers. You get the point? Is my point well
Yes,
made, my
please.
professors?
Yes, please.
Okay, okay, and quickly let's see, then we will end. I'm going to do the other one. Assuming the smaller number, okay, is what you represented by x, then the bigger number will be 2x. So let's see. So in that case, it will be x plus 2x is equal to what? 36. Am I right? Let's see whether that will make sense. Okay, so I'm going to get 3x is equal to what? Okay, 36. Am I right?
Yes, please.
Okay, so if I solve, I will get x to be equal to
12.
12. Now you can see that this time around, the x is for which one? The smaller one, is that not it?
Yes, please.
So when you are drawing your conclusion, it will be the smaller number one will still be 12. However, your bigger, no, the larger one will be what? 12 times 2 because of how you represented them. And that will still give you 24. So you end up getting the same result. So your representation, you change from the beginning. You get the point?
Yes.
Okay. So my professors, I guess my point is well made here.
Yes, please.
Okay, so okay, in our next meeting, we'll be looking at consecutive integer problems. We are still dealing with number problems, okay, or consecutive numbers, okay, problem. All right, now that you have understood the first one, dealing with this one will be very easy for us. Okay, so on this note, I would want to say thank you very much for sticking and staying with me, okay, for your time, for your contribution, okay, and what have you. Okay, God bless us all.